Now we will go to Israel. Revital Bookman from
Yes.
University of Haifa will present her research entitled Geomorphic Evidence of the Climatic Effect of Large Volcanic Eruptions in the Dead Sea Basin.
Okay.
So, Revital, the floor is yours. When
Yes.
you are ready, please share your presentation with us.
So I'm sharing my screen. Okay. Are you seeing my screen?
Yes, very well.
Okay. Thank you very much. So I'm very happy to be here and to present a work I've been doing in the Dead Sea. And I will talk about the geomorphic evidence for the climatic effect of large volcanic eruptions in the Dead Sea Basin. These are my colleagues, Sagi Filin, Yoav Avni, Daniel Rosenfeld, and Shmuel Marco. Although this work was done a few years ago, I thought it is a good occasion to present it again, because it's using geomorphic features in order to explain or to understand the hydroclimatic conditions. Today, I'm a part of the Leon Cherny School of Marine Sciences in the University of Haifa. Which is a relatively new institute, a new school that deals mostly with the forefront of marine academic research in Israel, and has four main academic departments: marine biology, marine civilizations, which is mostly archaeology, marine technologies, and I'm part of the marine geoscience department. So today, most of my work is being done in the coastal environment and in the sea, offshore. But I wish to present here work that can be considered more as a geomorphological work that I did in the Dead Sea Basin. So I really started my career in the Dead Sea Basin. That's where I did my PhD, and along the years, even so, I changed fields into a more marine environment. I continued working in the Dead Sea Basin, which is a really unique environment. So the Dead Sea, which I believe people know, is a hypersaline terminal lake located in a tectonic depression at the plate boundary. It has a relatively large watershed that encompasses both Mediterranean climate in its northern headwaters and semi-arid and hyper-arid environments in the southern parts of its watershed. So here in the image, you can see at the middle, in blue, the watershed boundary. At the middle of the picture, you can see the Dead Sea, the current Dead Sea surface, located within the Dead Sea Depression. And during the late Quaternary times, especially during the last glacier maximum, the sea level in the basin was much higher, and it reached all the way to the north, and it is marked here by the red border. Okay, so this is the surface area of what is called Lake Lisan, that was dated to 70 kiloyears to 14 kiloyears, and covers really a large time portion of the last glacier period. So what I did in this specific work with my colleagues is we wanted to look at a series of short terraces that are connected to the transition from the LGM time period to the Holocene, when Lake Lisan desiccated really dramatically with a dramatic lake level fall, reaching the current day sea level or lake level, which is around 400 meters below sea level, the deepest inland place on Earth. So these shore terraces or shore ridges that you can see here in the figure are horizontal strand lines, very beautiful, exposed on the margins of the basin of the current Dead Sea. And along the years, it was known that these shorelines represent the desiccation of Lake Lisan, and their significance in terms of their morphology or their elevation was not given a lot of attention. And it was explained by, the lake was retreating, so it left these shorelines. But I don't believe that anything in our nature is arbitrary, that there is a significance for everything. And we raise the question, what is the hydroclimatic significance of these terraces? While doing Lake Lisan desiccation, we see these marks on the margins of the basin. What do they represent in terms of hydrology and climate? So the next step was to get a really good 3D surface LiDAR scanning of the western Dead Sea Basin margins. And you can see part of this scanning here. Really nice to work with LiDAR scanning, high resolution, really beautiful. You can see here the Lake Lisan desiccation shore terraces. But at the same time, you can also see the modern Dead Sea shore terraces. These shore terraces are appearing today because the lake level is dropping, mostly because of anthropogenic reasons. And we have almost every year a step in on the retreating plains of the Dead Sea, marking the previous year. So, of course, these ones, we knew that there were the modern Dead Sea steps, we knew that they were annual, but the Lisan desiccation steps were obviously not annual because their number was not representing any annual record. So we wanted to continue on working that and to understand what is the relevance or the significance of these shorelines. So this is the map of the terraces. We mapped them, and this is again a small representation of the mapping. You are seeing here 16 shorelines that were seen in the elevation model and in the LiDAR scan. And each of these steps represent a time period or a lake level during a specific time period during the desiccation of Lake Lisan. On the right, you can see we use the DTM of our region in order to show the surface area that is covered by the lake at each step, at each terrace. And this is the highest one at 275 meters below sea level. And as the lake level is dropping, we see that the lake is shrinking. We also used it in order to calculate the amount of water that we have between each step. Okay, and in a minute you will understand why it was important for us. And in red here you can see the modern lake level that is dropping all the time. And today is below minus 430 meters. It is dropping at a rate of more than 1 meter per year. And an important thing also, we were able, using the LiDAR scanning, to get really good estimate of the height of each terrace. And again, it was important for us in order to calculate the amount of water that each step represents. Okay, so then the question was, what is the geomorphic process responsible for those terraces? What exactly happens in terms of the geomorphology at the shore lake that is responsible for the creation of these terraces? So it's not a big surprise. We know why we get these steps. But again, we wanted to know exactly what is the hydroclimatic response. So first of all, it was presented really back in time in 1971 by Dan Bauman. What is the process that he thinks is responsible for the generation of the development of these terraces? So this is a schematic illustration from his paper, and you're seeing here the lake level dropping, but it is not dropping in a straight line, of course. It all depends on the resolution that we are looking at. And of course, what he thinks is that during short time intervals, when lake level obviously is dropping, we have a short term lake level rise. Okay, for some reason, the drop is stopping and we have a short level rise. And during this short level rise, this is a drawing explaining what exactly happens. During the lake level is dropping, we have a short-term level rise. During that time, we have a terrace development. And when the level is dropping again, we have a terrace relict. If sea level, lake level, will rise again, because the main trend is going down, the next level rise will not erase the terrace relict and will create a new one. So we have an understanding of what is the geomorphic process responsible for the development of these terraces. Then the question was, what is the hydroclimatic event recorded in the terraces? What kind of climatic event can be responsible for that? For that, we needed to know what is the age of these terraces. So it's really difficult to date this kind of geomorphic features, which you probably know. And we used their elevation in order to determine what is the time period that when do they really developed. So this is the Lake Lisan level curve, which was reconstructed in a few phases, but this is the main outcome of the lake level reconstruction. And since we know that this kind of terraces are a relict, we understood that they cannot be representing a lake level change during the rise of Lake Lisan, because each time the level will rise, it will erase the previous terrace. So it means that it happened during the drop of the lake level, and I think it's quite obvious. So we used this lake level is the high. It was dated really in high accuracy, and there are good dates for the top of the Lisan formation, the lacustrine formation that was deposited during the high stand, and there is a good estimate of the base of the Holocene, the lower part of the record, and in between we have 16 short terraces that are based on their elevation needed to develop between 14.5 thousand years, a date that was reached using uranium series dating on the lacustrine sediments, and a bottom age of around 13.2 kiloyears, based on organic material from lacustrine sediments. So approximately we have a terrace every century. Okay, so if I showed the recent shorelines that are representing something that is annual, in this case we are seeing an event of short terrace development every century. So here we asked ourselves, what kind of a climatic event is occurring at a scale, at a frequency of an event per century? In order to answer that, we went back again to the modern analog and tried to see if we have something that can represent these short terraces. And we are looking here on the last 100 years or more, 100 and 200 years of the Dead Sea lake level curve, how it was reconstructed by Tzipora Klein somewhere in the 60s and 80s. And you can see here both the historical shorelines and both the modern shorelines, okay? And basically each step represents a year. The sea level is mostly dropping since then, but you can see that we have these small peaks that are representing small short-term increase in lake levels. So we looked for a modern analog and we found out that we have a really significant short terrace that was dated based on its elevation and also based on observation to the winter of 91-92. This was an anomalous winter and a very extremely wet winter. During that winter, we have a development of a 2-meter terrace. Most of these terraces are only a few centimeters to, I don't know, 20 centimeters high. And in this case, the terrace that developed during that winter was 2 meters high, a very distinct terrace that we also saw it in the LiDAR scanning. And it was developed during a very wet winter with above annual precipitation. This condition created meromictic conditions in the lake where we have a stratified lake. We had a bloom of cyanobacteria, something that is really rare in the environment of the Dead Sea. So it was a very wet and spectacular winter. During that winter, there was, prior to that winter, we had a volcanic eruption. And we thought that by analyzing this modern analog, we will probably be able to find a good candidate for this climatic hydrologic short-term events. So as I said, it was a very wet winter. We had a lot of snow during that winter in Israel, which we usually don't have. It was very cold. And this winter was following the Mount Pinatubo eruption in June 1991. This is the lake level record, and this is the beginning of the winter, and this is the end of the winter. During that winter, following the eruption, we had large amount of aerosols that were injected into the stratosphere, and they were disturbing the atmosphere in terms of its meteorological conditions, and we had a global temperature drop of about half a degree. And it was a global event. It was expressed all over the globe, also in our region. And you can see here the precipitation average in millimeters per year from a rain station in Jerusalem that is recording the rain since the 19th century. So it's a relatively very long record of precipitation. And you can see how the winter of 1991 to 92 is really above the average, which is about 540 millimeters per year. So it was an extremely wet winter in our environment. So the atmospheric effects of volcanic eruptions are well known. I did not discover anything new, and this is a review paper by McCormick in 1995 that was published in Nature. And there are different atmospheric effects depending on the geographical location of the volcano and so on. But the main things that are important for our story here is that we have the injection of a lot of aerosols and that the surface cools down. Okay, so globally it was a drought year. It was a drought year because surface cools. We had less evaporation and less rain. But in the Eastern Mediterranean, we had a very specific condition where the cool surface of Europe was responsible for cold air masses that were passing with the Israelis over the Mediterranean. The temperature gradient between the atmosphere and the sea, which was of course warmer, created a lot of evaporation. And in Israel and the entire southeastern Mediterranean, we had much higher precipitation during that year. So the Pinatubo eruption created a condition where we have colder temperatures and much higher precipitation rates in the Mediterranean, southeastern Mediterranean. Okay, so we had the modern analog of the Pinatubo, but we wanted to check if we see this connection also with other volcanic eruptions that occurred in the last 150 years. So this is a record of the volcanic eruptions that are known. Most of them are smaller in scale than the Pinatubo, okay? And we are looking here at the amount of rain, the average annual precipitation in the Jerusalem rain station, and the dust veil index. This is an index that represents the amount of aerosols in the atmosphere. The higher the index is, the higher we expect the climatic effect because of the volcanic eruptions. So you can see that there is a correlation. It's a positive correlation of 50%. Of course, because these are smaller scale volcanic eruptions, it is expected that other atmospheric perturbation will be responsible for the amount of rain that we see in Jerusalem. But overall, there is a correlation. When we added to our statistical analysis by using a multiple regression of predicted rainfall versus the actual rainfall, and we added other oscillations like the Southern Oscillation and the North Atlantic Oscillation, we saw that there is some influence by the Southern Oscillation. We use the Southern Oscillation Index, and when incorporating it into our statistical analysis, the regression increased to 60%. So what we saw here is that we have a modern analog for the connection between volcanic eruptions and rain over the Dead Sea Basin watershed during modern time, or during the last 200 years, when we have instrumental records both of meteorological conditions and, of course, the volcanic eruptions themselves. So the next step was to go and look for a record that can show me or can present volcanic eruptions that happened in the past. So that was a little bit challenging because I didn't have any idea where to look for a record. But then I realized that the best record for that will be the Greenland ice cores. Ice cores record global climate conditions, but and they are famous for that, mostly the Delta 018 record, but they also record dust that is being deposited in the ice and buried with the accumulation of ice. And for example, if we see here, this is the last 20,000 years, we are seeing the calcium concentration, which represents the trittle dust, and we can see the LGM high record and the Younger and Dryas. It is also recording volcanic ash that is represented here as sulfate. So we had individual layers with high concentration of sulfite that represent individual volcanic events. So when I saw this record, I understood that it will be possible to try and correlate my lakeshore record from the Dead Sea with specific volcanic events that happened in a specific year. So how did we do that? First of all, one of the main keys for that made me think that this is a possible record to correlate is that in the paper that was presented by Zilietsky and his friends on the ice core record of volcanic eruptions, they had a projected number of eruptions, a graph presenting that, and an average of an event once a century. And if you remember, I calculated from the short terraces an event once a century. So this, light my imagination that maybe we are seeing the evidence for the hydroclimatic evidence for volcanic eruptions in the Dead Sea Basin. So this is the table that they presented. They had they dated each volcanic eruption event, of course, using a chronological model of the ice record, and they have both the age for each event, but also they have the concentration of sulfide, the concentration of aerosols, volcanic aerosols. And the main assumption was that the higher the concentration is, the higher the volcanic eruption was. Of course, it's a little bit more difficult or more complicated than that, and it depends also on the geographical location of the volcano. But it was a good estimate to connect between the concentration of the aerosols and the possible impact of the volcanic eruptions in terms of climate. So this is the correlation that I created. In a minute, I will show it in a graph between the terrace. These are the 16 terraces, their elevation and height. From the height, we calculated the amount of volume of water that was needed in order to increase the lake level to create the short terrace. And this is the sulfate concentration. This is the signal for the volcanic eruption and the year of the signal. Of course, it's a modeled age. It's not that they were able to calculate specifically the age of each sulfate horizon. However, when I put them, I played statistically quite a lot with that. When I put them each one in front of the other, I was able to get a quite good correlation between the volume of water that entered to the Dead Sea Basin in order to reconstruct the short terrace and the concentration of sulfate. So not only that I was able to show that the frequency of the event is similar, and that's why I establish a correlation, but also I found out that there is a connection between the amount of volume of water that is needed to develop a short terrace and the intensity, the magnitude of the volcanic eruption. And of course, the higher the the larger the volcanic eruption, we expect the larger climatic effect, and of course, more precipitation that is represented in the volume of water. When this was the correlation that was achieved was about 50%. When I deleted the smaller volcanic eruptions that, as you saw in the modern analog, are reducing our correlation because other atmospheric factors can affect their influence on the climate. When I deleted them, the correlation even increased to 80%, which was really high. Okay, so I will conclude my talk. This paper was published a few years ago, and I showed really nicely how a short terrace record, very simple short terrace record, which was there for a lot of years and was never considered to have any climatic significance, but the drop and the transition from glacier to interglacial conditions, when we are looking at really high detail on our record, sometimes we can see a lot of additional climatic events. And these details events can provide a demonstration of global climatic teleconnections. So we can learn from this kind of records about atmospheric circulation and the effect of climate at different geographic locations. So thank you very much. I will stop my sharing. Yes.
I'm not sure we have time for questions because we are already 10
I have a
minutes late.
question. May I?
So,
Yes.
May I? I have a
Yeah,
question.
sure.
Monique?
My question that takes.
well, only one question. So, have you a question, Amir?
Anya, or I have a
Amir,
question.
do you have a question?
Yes, please. Can I ask something?
Yes, go ahead, but make it
Do you
short.
hear me? Okay, it will be short. Thank you very much. Fascinating. Now, can you tell me, are there similar evidences in other places or in other environments or locations?
Yeah, so I need to add that this is a very rare condition because in order to really record these short terraces, we needed to a really large climatic transition that on top of that, we saw the short-term climatic fluctuations. But it does, you can see it in other places in the world. For example, I looked for the literature for other evidence. So there is a lot of evidence for short terraces in different places, especially in arid environments where you see them really nicely. And I'm sure it can be this kind of short-term intervals of climatic change can be traced in other places. I have a few examples. We don't have the time here to show them, but I'm sure I will be happy to collaborate with other people trying to detect this kind of short-term climatic events. Yeah, sure.
Sorry. So thank you very much for your nice
So people
presentation.
can
Yeah.
email me if they want to ask more questions. I will be really happy to answer them.
There are already more questions to be asked, and Sunil Kemar from India wants to ask. He's saying, nice work and presentation. I have one curiosity to know from your ice core study, you have found there were several volcanic eruptions in the Dead Sea Basin. Does the terraces along the Dead Sea show any signature or volcanic rock character? And secondly, even it is so, it is not too short time, 100,000 years to change the rock character. Please try to answer very, very quickly because you are 10 minutes, you have taken 10 more minutes than...
Okay, so I will just say that an important thing, we are not seeing the volcanic eruption in the Dead Sea. The volcanic eruption happened somewhere else. We are seeing the indirect hydroclimatic effect on the Dead Sea Basin. So it's not the volcanic eruptions that we are seeing in the lake. So we don't see any evidence for the volcanic eruption, but the hydroclimatic effect of it.
Does this indicate that during Pleistocene there were many volcanic events? This is what Professor Sunil asks also.
Yeah, well, not in the late Quaternary, but there is evidence that there were increased volcanic activity during the transition from the LGM to the Holocene. And the reasons for that are connected to isostatic changes. I'm not an expert in that, but if you will look at the papers by Zelitsky that I presented in my PowerPoint presentation, you can see that there is an increase in during that time period.
Okay, thank you very much. And